Hello students, hope that all of you are in good health. I advise you to be at home whenever you want urgently to go out, wear mask. It is our responsibility to keep healthy and remain safe. Welcome to the second session of science class. Before I start, I want to have some observations about the first assignment you have done. I'm happy to see that most of you have done your assignment well, and most of your answers are also right. But it is sad to see that some of the students have not submitted the assignments. In future, please cooperate actively. Welcome all to the second session. We start our science class formally. Before I start, I want to give you some instructions. First of all, most of you do not have the test book, I hope. Those who have the book, as a lesson is going on, no need to open. You go through the book only when I say. Secondly, you get ready with a rough book and a pen. We want to do some writing work also, otherwise you will get bored. Third point, after every class, I will give you some questions and answers that you write down your classwork book. After the reopening, I will go through the notes. And for that, as we were doing last year, you buy a 200-page book and start writing the class notes. So let's start with the new academic year. And you might have seen your textbook. Those who have the book, please take the content page. There you see a list of 16 lessons. First 5 lessons are chemistry lessons. 6 to 9 life process, the physiology. So of course they are a part of biology. And from lessons 10 to 14, physics. And 15 and 16 a separate 2 lessons are given, which are actually part of biology, but they are general biology, and therefore they are separately given. So this will be the arrangements of the lessons we have to learn for the year. So we just start with the first lesson, chemical reactions and equations. Chemical reactions and equations, and we have some idea about chemical equations and reactions. We learned something last year, and we go in detail, and some more details we learned this year. So as I wrote here, chemical reactions and equations. Now please take your rough book and write the heading and put the date. And if you go through the chemical reactions in our day-to-day life, some of the examples we can go through. So we know certain changes that take place in the nature in our day-to-day life, everyday life. Some of the examples I wrote already here. We know that in summer season, milk gets spoiled if we keep it open for a long time. Another change you see if you add some buttermilk into milk and keep it for some time, and that is transformed into a semi-solid substance, a thick substance we call curd. And some other changes also we see in our day-to-day life if you keep on overnight things and materials and they get corroded. We call rusting. A coating of rust is formed on iron. And of course the digestion of food, after taking the food is digested, food is converted, is broken down in the stomach and energy is produced, we learned last year. Then we see the respiration is also a chemical reaction, and of course food materials are cooked and there also. So something common. So please write down some of these examples in your book. Okay, back. Now if you go through these examples, have you seen anything common in these reactions? If something come to your mind, please write down what common thing you see in these examples, day-to-day chemical reactions which we saw. If you observe these examples, there occurs some kind of change. The nature and identity of the original substance change. If you take the example of milk, milk is converted into another substance while adding 1 or 2 drops of buttermilk, or due to the bacterial reactions, milk is transformed. You see a change. That means the nature and identity of milk is totally changed. And in all these examples you see the nature and identity of the substance, original substance change. Now just you think, what would be the reason for such a change? The nature and identity of the substance change. If you have an answer, please write down the nature and identity of the original substance change. Please. As you saw last year, we studied the differentiating points between physical change and chemical change. To produce a basic change in a chemical substance, there should be either physical or chemical change should take place. A chemical change means the nature and identity of a substance change. So a chemical reaction means there is interaction between certain substances. So a chemical reaction produces a change, and that change, the nature and identity of the original substance change. Now we come to more examples to understand chemical reactions. As given in your book, there are 3 activities given for us to go through. The first example is about the burning of magnesium ribbon in air. Magnesium ribbon in air. A piece of magnesium, when it is burned in air, that means with oxygen. Before burning a magnesium ribbon, care should be taken. Magnesium, you know, that is a reactive metal. It can react with oxygen in the air and form a chemical substance called magnesium oxide. Magnesium forms magnesium oxide, and it remains on this metal. Therefore, usually a magnesium ribbon reacts with oxygen and form magnesium oxide that will be found on the surface of this metal. Therefore, as we burn a magnesium ribbon, it may not burn brightly. So, in order to avoid this, we rub it with a piece of sandpaper. There is one question in your exercise. The piece of magnesium is rubbed before burning with the sandpaper. The reason is this: to remove this magnesium oxide, therefore it can actively react with oxygen. So while burning this magnesium ribbon in air, a reaction occurs. Of course, magnesium now reacts with oxygen and form magnesium oxide. Magnesium oxide is formed. And another activity is given. A second activity take a beaker. This is a test tube. Two aqueous solutions are taken in the test tube. One is lead nitrate, PbNO3 twice. And another chemical substance taken is aqueous potassium iodide. Two chemical substances are taken in a test tube. And on this reaction between this lead nitrate and potassium iodide, two chemical substances are formed. Let us write the chemical reaction in the form of a chemical equation. PbNO3 twice plus potassium iodide gives, as we learned last year, lead nitrate will be dissociated. Potassium iodide also will be dissociated during chemical reactions, because these part of the chemicals are metals and they will be dissociated. Last year we studied different types of compounds, ionic compounds and covalent compounds. They are ionic compounds because here this part is metal and here also metal. Ionic compounds, and of course during chemical reaction they will be dissociated. Remember, last year I told you that a chemical reaction, the summary of a chemical reaction, there is breaking and making of new bonds. We learned about chemical bonds last year. Breaking and making of new bonds. And of course here also the potassium nitrate is broken, potassium iodide, lead nitrate is broken and potassium iodide is also broken. And new substances formed, rearrangement of these chemicals. So Pb goes with iodine and form lead iodide is formed. Lead iodide. What is the meaning? Let us see. Here nitrate is left and here potassium is left. And therefore potassium and nitrate react to form or combine to form a chemical substance called potassium KNO3. For balancing this, okay, we are coming to the next topic, balancing of chemical reaction, but it's a need for balancing a chemical reaction and we have to balance this. And here you may see that Pb only one atom and here also Pb one atom, but here, so you have to balance the oxygen and nitrogen. We will see the details later. And here we have PbI2, potassium, lead iodide, and because here two atoms of iodine and the multiple 2 has to be added here as a multiple number or a coefficient we call. And here also to balance this oxygen, here 3 2s are 6. And therefore here 2KNO3. So the equation is balanced. PbNO3 twice plus 2Ki gives PbI2 plus 2KNO3, potassium nitrate. But you have to see here, these two chemical substances are aqueous solutions and also colorless. But when it comes to PbI2, there is a change. And it becomes yellowish in color. There is a color change in the... So, here the original substance, as I told, that chemical reaction, the original substance lose their nature and identity. And here PbNO3 lose their identity and also potassium iodide. And here you see new substances are formed, entirely different new substances are formed. Their color change we observe and the reaction we see. Now we go through this third activity. Third activity, we use a conical flask. Closed with a cork and a funnel is inserted. Before we close the conical flask, put some zinc granules in it. So zinc granules are put. I am using a thistle funnel and dilute H2SO4 or HCl, any acid, sulfuric acid or hydrochloric acid. So by adding hydrochloric acid, let us use as per your textbook, hydrochloric acid is used, and as you add hydrochloric acid and the zinc granules, the following reaction takes place. Zinc is a metal, solid metal, zinc plus HCl. We use, remember, HCl is dissociated and zinc is a metal. And it goes with chlorine and forms zinc chloride. Zinc chloride formula is then Cl2. So we get the clue that here should be 2 as a multiple to balance this chlorine. So zinc chloride is formed and what is left? 2 hydrogen atoms left. And to these 2 hydrogen atoms to form a molecule of hydrogen. And this hydrogen gas is evolved during chemical reaction. Now you see that here zinc is a solid substance, we write here as, and here it is an aqueous solution, is a liquid, and the zinc chloride, that is also an aqueous solution, but here hydrogen is a gas. So you see, some kind of changes we see in all these 3 different types of chemical reactions. 3 different types of reactions. Now we come to see that what are some of the observations at the end of these 3 different activities given to us. We see that there are 4 observations by which we can understand that a chemical reaction has already taken place. 1. You may write down in your book what are the observations by which we can understand a chemical reaction has taken place. How do you understand? A chemical reaction occurs. And so many changes we saw in the first section. I saw that the ordinary chemical reactions that take place in our day-to-day life. And there also you can apply these 4 observations. And chemical reactions you saw, the 3 activities. And there also we see these 4 observations. The first observation, state change. There is a change in the state of matter. So state change. Give the example, state change. The last one you take, zinc and hydrochloric acid. There you see that I told just now, hydrogen gas is evolved. In reactants, you don't see any kind of gas, but in the product you see gas is formed. So there is a transformation, there is a change, there is an observation that gas is formed. Then color change. color change. In the second example you saw, there is color change. I told you that the lead iodide formed, lead iodide, and there is yellowish in color. And the original substance we took, both are colorless solutions. So there is a color change. Then sometimes there is a change in the temperature. Temperature. The third example we take. If you just touch the conical flask, you may feel the warmth. And this kind of reactions where heat is evolved, and further we will see, called exothermic reactions. So temperature, and that also another change we see, another observation that occur during chemical reactions. And another observation, we can also find the evolution of gas. So here we write change in temperature. Change in temperature. I write the fourth form, TMDT, temperature, and change the last one. There is a change. And what is that change? Evolution of gas. So all these are some kind of changes take place, and we can consider it as what? Observations by which we understand that a chemical reaction has already taken place. Now we move on to the first part. Now just we have a look into the first part of our session. We saw that what are some of the chemical reactions take place. What are chemical reactions? Now we see that chemical equations. Chemical equations. Chemical equations. What is a chemical equation? A chemical equation is a summarized form of chemical reaction, or is an abbreviation. It's an abbreviated form of chemical reaction. If you take the example of the entire story of the burning of magnesium in air, it is very lengthy and space consuming. Therefore, scientists have come out with simple method of expressing chemical reactions. Two different ways a chemical reaction can be expressed. One, so we write chemical reaction. Chemical reaction can be expressed in two different ways. One, chemical equation. Chemical equation. And the first one, word equation. Word equation and chemical equation. We take apart this word equation. Take simple example. The burning of magnesium in air. Already we studied magnesium reacts with oxygen to form magnesium oxide. Magnesium oxide. In this reaction, we write two different ways. One, a chemical equation, and also in words we write, instead of magnesium, we write magnesium in words. Magnesium plus oxygen gives magnesium oxide. So this is the way word equation is expressed. Magnesium plus oxygen gives magnesium oxide. This kind of an equation is called word equation. Rather, if you write the same equation using chemical formula and the symbol, then it's a chemical equation. So, what's the difference between word equation and chemical equation? In word equation, we use the equation in the form of words, and in chemical equation, we use symbols and chemical formula. Then, again come back to this word equation or the chemical equation. We see certain symbols used in this equation. In both these equations, we see some symbols. First, we take up the arrow mark. A chemical equation has two parts, whether it is a word equation or chemical equation. An equation has two parts. The left hand side we call LHS, and the right hand side of the arrow mark we call RHS. The left hand side of the equation, they are called reactants, and the right hand side of the equation we call products. So an equation consists of two parts. Whatever coming in the left side of the arrow mark, that is the reactants, and the right part of the equation that is called the products. So an arrow mark divides reactants and products. And here you see plus. The plus symbol that indicates how many reactants react to form the product. And here we see only one product. Certain reactions we see more than one product. And in this case, plus is also used in the product side to express the number of products. So this way, symbols are used to designate the reactants and the product. So chemical equation and chemical reactions we learn. Then what is the need for balancing of chemical reactions? So the next topic we will learn balancing of chemical reaction. Balancing of chemical reactions. Balancing of chemical reactions. What's the need for balancing a chemical reaction? Is it necessary to balance a chemical reaction? Of course, it's necessary to balance a chemical reaction because it has to fulfill the law of conservation of mass. We learned last year what is law of conservation of mass. Law of conservation of mass states that in a chemical reaction, the mass of the reactants, total number of the total mass of the reactants and the total mass of the product remain the same. That means the number of atoms of elements react and the number of atoms of elements formed in the product, and that remain the same. Then only a chemical reaction is balanced. So here the mass balancing as well as the number balancing. So we take the example of the formation of magnesium oxide. Magnesium reacts with oxygen to form magnesium oxide. This kind of a reaction we call skeletal chemical reaction. Skeletal chemical reaction. Skeletal chemical reaction. What does it mean? Here you see that the number of atoms of each element, if you take here one atom of magnesium reacts with two atoms of oxygen to form magnesium oxide, where one atom of magnesium and one atom of oxygen. Here magnesium is balanced but oxygen is not balanced. That means the total mass of the reactants, if we take the number of atoms of each element, and here the product is not balanced. Therefore, it is necessary to balance the chemical reaction. So a skeletal reaction will give you the frame of a chemical reaction, or we can say that is an unbalanced chemical reaction. A skeletal reaction is unbalanced chemical reaction. Then come to balancing of chemical reaction. In a chemical reaction, balancing we follow a general rule. Whichever the reactant or the product, whichever is having more number of atoms, and we consider that and balance that in the equation. In this case, you see that the oxygen atom, two atoms of oxygen, but here magnesium has only. So here we go to oxygen for balancing it first. But one thing you notice that in the chemical formula, every chemical formula, the chemical formula is formed by the combination of a specific ratio. The number of atoms react to form a compound in a specific ratio. Therefore, we cannot change the basic chemical formula of a compound. So, magnesium oxide, we cannot balance the magnesium oxide by putting a 2 as a subscript below oxygen. So, it will change the chemical formula. So, it is not possible because here magnesium oxide has a particular ratio of magnesium and oxygen to react and form its compound. Therefore, magnesium oxide we can balance by putting 2 as a subscript number or as a coefficient here. So, magnesium oxide now balanced in magnesium oxide, oxygen is balanced by putting 2. By doing so, we unbalance magnesium in the reactant side. Therefore, to balance that, we put 2 as a coefficient or a multiple number. So, the reaction now is balanced. 2 Mg plus O2 gives 2 MgO. It's a balanced chemical reaction. Dear students, we wind up the class here today. I will come to you with more examples and more topics.